Hi guys, this is the video for investigation for part 2, diffusion and osmosis. And in this activity we are going to be modeling diffusion and osmosis using synthetic cells. Synthetic cell membranes are made out of something called dialysis tubing. When I hear the word dialysis tubing, I think of an actual tube, and yet when I hand it to you, it's not going to look like that at all. So I'm going to start by showing you what it is that you're actually going to be working with, and then the easiest way for you to work with it, and then how you're going to go ahead and collect your data. So when I hand you your stuff at the beginning, you're going to get this. This is dialysis tubing. It looks two-dimensional, and there's no tube there to speak of. You're going to get a meter of it, and the first thing you need to do is cut it into 20-centimeter chunks. And so there's a ruler in your tub, and then there's scissors in your tub, and then just cut it into chunks. So once you've done that, the only way you can really work with this stuff is if you use water, soak it in water, and that's how you can actually make it look like a tube. So first thing you do, cut them up, put them all in water, in a beaker, or in one of your cups. You're going to be working with these guys for cups. And then this is not easy. It's important I tell you that so that you don't get frustrated. Once you have it in the water and it's soaked and it's nice and pliable, you rub it between your fingers until you actually can see the two different layers of your tube. And it looks like you can kind of see there. It doesn't film very well, but you can see it's actually a tube. Now you cut it open, and so you have a tube that's open on both ends, and you're trying to make a cell. And in order to make a cell, you have to tie off each end, and then you're going to have one fluid inside the tube and a different fluid outside the tube, and you're going to see how diffusion and osmosis is working. So to tie it, we're going to use dental floss, okay, which is also in your tub, and you just rip off a piece. And this is absolutely a two-person task, which is why I'm not going to be able to do it for you by myself. But you take your tube that's wet and it's more tube-like and less flat than it was when you started. You take your tube and you double knot around one side in order to seal it off. And this needs to be done tightly. Otherwise, your fluids are just going to pass through the ends of your tube. And you're going to see a weight change, which is great, but you're not going to be able to see a weight change that's due to osmosis and diffusion. You're going to see a weight change due to leaking, which is not useful at all. So you double tie the ends, and again, like I said, it's easier with two people. And so one person holds the top, and then the other person double knot here. And then, if it's gotten kind of stiff and hard to work with, dunk it back in your water. And in fact, what's probably easiest is if you tie the end of all 5 of yours off, and then put them in the water, and then once you've got one end tied on all 5 of your cells, then come back for this step 2. What you do then is make sure there is nothing in the tube. You don't want to have any water in the tube at this point. Then you open it up, again, two-man task. If you want to use a funnel, you can. You can put a funnel in the tube part here, okay? Or you can just use your 10 mil graduated cylinder and pour, whatever is easiest for you. And so you open up, one person opens up the tube like this, and then the other person has measured out their 10 mils and pours it into the cell. And so once you've got that into the cell, you can't put it down, and this is why you're working in a group. Somebody's going to have the top pinched off. Your fluid's going to come up to about here. You're going to leave some airspace. Because you want to have room for those fluids to move around. And so if water is going to be going into the tube, you want room for that to happen. So one person's going to hold, the other person's going to tie up near the top of the tube, and that's going to be your cell. You're going to do this for all 5 of the pairings that are in your lab notebook. In the College Board book, it says that you can pick your own pairings. It's easier if you just do the ones I tell you to, because then your data will make more sense. So I tell you what your pairing should be, what should be in your dialysis tubing, and what's going to be the solution in the cup. You use these cups. We reuse these. Do not throw them away. And then you should have Post-its in your tub as well, so that you can mark what is in each tube so you guys don't get confused. So once you have your cells created with the proper solution in it, and once you have poured this proper solution in your cup, you find the mass, the initial mass of those fake cells, and then you put them in the cup. Then we let them sit for all of lecture. It says in your book to let them sit for half an hour. We're just going to let them sit for however long I lecture. And then at the end of the class, we take out our cells, dry them off, because you don't want to have all that extra mass on the cells themselves. They need to be about as wet on the outside as they were when they went in, so that you're consistent with that. Find your final mass, and then find your percent change. There's a lot of math that goes along with this. We'll talk about that in class as well, but that's just how you get your data. For this lab, what you'll turn in is just the lab notebook again. There's not a cover page or anything like that, so you'll just rip the pages out of your lab notebook. There are a few conclusion questions down here at the bottom, and that will involve some calculations, so just be prepared for that, that this is not something that you type, but you're going to have to do some math in order to answer those questions. Thanks for watching my video. Have a good day.